Okay, so this is just going to be a quick demonstration of how to graph sine and cosine along with some transformations. And I'm not going to go into a whole lot of depth. I just want to do one good example of each just to get you going. And let's start with just the parent functions, okay? So what you're going to see is an equation written as a function, y equals the sine of x. That could be a theta, that could be an alpha, it could be really anything, but it's just our variable. And when you graph these, they're both waves. Now, sine and cosine both, I usually only guide myself with the four main axes, meaning, we start at 0 on the unit circle, and then the top of the circle's pi over 2, and as you're working your way around, you'll hit pi, and then 3 pi over 2, and then of course 2 pi, and then you can keep going around the circle. So these graphs are going to repeat once or rather keep going, but I'm just going to show the main part of the graph from 0 to 2 pi first. So how do they work? Well, sine, if you just look at the points, remember sine is a y value. So at 0 degrees, the y value at the unit circle is 1. At pi over 2, what is the y value on the unit circle? It's 1. At pi, the y value is 0. At 3 pi over 2, the y value is negative 1. And when you're back to where you started, it's back to 0. So when you play connect the dots with this, you get this beautiful little curve or wave. Yeah, I said beautiful, but mine looks kind of scrawny, but you can make yours pretty if you like. But that's what the parent looks like. And like I said, it keeps going. So it would just keep on doing the same thing, over time. So, but if you memorize that, you're good to go. Now, for the same reasons, cosine's also going to look like this wave. It's just going to be shifted over because, remember, cosine means the x value of the circle. So at 0, the x value of the circle is 1. At pi over 2, the x value is 0. At pi, the x value is negative 1. Back to 0. And then at 2 pi, the x value is 1 again. So, and please don't connect these with a line. This is the same wave as this. It's just been shifted, so you better make sure you've got a lot of curves going on here. Oh my gosh, I'm kind of embarrassed at how badly I connected the dots. But it is a nice, smooth, pretty curve there. Okay, and once again, also, yes, keeps going, and there you have it. So these are your parents. Now, what can happen is any one of the following transformations, or what usually happens. Usually you might see, or you could see a negative. You could see a vertical dilation. And then you'll see your parent. I'm going to start with sine. Now, you could also see another dilation right here, maybe a right or left shift, and then maybe an up or down shift. So these transformations do the same thing you've known since Algebra 2. Like I said, reflection, vertical dilation, horizontal dilation, left, right, up, down. Now, the only thing is they have special names now. So, your A, you don't want to, you can call it a vertical dilation, but it's also a new amplitude or a change in amplitude. And it's called that because the amplitude is a measure of something's height from the center. So, like the center of the sine graph is here right now. And then you go one away this way, and you can go one down this way. So the measure of the height of this is 1, and that's what the amplitude is. The B right here affects the period, okay? What it's going to do is it's going to change the period using the formula 2 pi over B. Now, what the period measures is how far you travel before you repeat. So on the parent function, this graph travels a distance of 2 pi, then the graph starts to repeat, okay? So if there's a number there, we're going to plug it into this formula, and that's going to tell us how much to stretch this horizontally, okay? And I'll give you an example in a minute. This is just like normal. If there's a number here, if it's a minus, you're going to go to the right. and if it's a positive, you're going to go to the left. The only thing about this is the right and the left have kind of a new vocab name here. They're called a phase shift, okay? And then the D is a normal up-down, just like you have grown to know and love it, and there's no fancy name for that. Okay, so there we have it, all the different things that can happen. Let's do an example. All right, so as an example, let us graph y equals negative 1/2 sine of 3x. Okay, so the way that I would approach this, and I'm actually just going to draw right on top of my parent function up here, okay? The way I would approach it is I always graph the parent first, which I already have done here, yay, just so I can see it with my eyeballs, and then I work left to right. This negative in the front is going to be a x-axis reflection. So what I'm going to do is just draw that first. Now if you want to do a dashed line or do different colors, that sometimes helps you until you get good. And then you can, and what I usually do is I'll draw the first one, and then I sometimes even erase the one before. So I would probably do that. So I've changed my parent with a x-axis reflection. Now I'm going to handle the 1/2. Now the 1/2 is a vertical dilation slash new amplitude. New amplitude of 1/2. So what does that mean? Well, it means instead of going down to -1, it's only going to go halfway down. And then instead of going up to +1, it's only going to go halfway up. So it changes your lows and your highs to 1/2. So like I said a minute ago, once I draw the new reflection, or the new transformation, I usually erase the old one. Come on, man. There we go. Cool. All right, so now I'm up to blue. The last thing that I see is sometimes the hardest for people. It's the hardest for me. It's the horizontal dilation. This number means two things. It means that I'm supposed to see 3 of these before I get to 2 pi, so I need to shrink the crap out of this and have like 1, 2, 3. Okay, that's one way of looking at it. Another way of looking at it is to say that I'm going to have a new period of 2 pi over whatever this number is. So, and it is always 2 pi up here, so 2 pi over 3. So what that means is that I want to see this blue graph, but it's going to stop at 2 pi over 3. Now for me, the easiest thing is to change my scale on my x-axis, and instead of making this a 2 pi, I just go, oh, that now needs to be 2 pi over 3. That's easier for me than drawing 3 of those little things and cramming them in. But the thing is, once you change your scale here, you need to change all of these. So what I did was I just took that 2/3 and I divided it by 3, or you could say I multiplied it by 1/3. That's probably easier to think about. So if I take 3 pi over 2, if I want to divide that by 3, that's the same as multiplying by 1/3, which means that's now a 6. Pi times 1/3 is now that. Pi over 2 times 1/3 is now that. So you can see how every single thing on the inside was changed. And once I do that, then I'm like, oh, and then it's going to keep going. There you go. So that's how I handle transformations, okay? I'm going to quickly do one more using the cosine graph. And then, hopefully, you will be good to go. All right, so what if we had y equals, let's do 3 cosine 4x plus pi. Okay, I'm going to do that. Now the reason I'm doing this one is kind of tricky. I had shown you an equation earlier with what every single part does. This 4 is going to be a problem where it's located. What you want to do is that if the 4 is inside the parentheses, you actually want to factor it out before you ever start. That way you can use transformations more effectively. So if I take a 4 out of both of these, it's going to leave an x here, and then I need to divide the pi by 4. So it's going to look like that. Now the reason I do that, guys, is so that I can clearly see. There's my A, there's my amplitude. This is my B, so my new period is going to be 2 pi over 4. I guess that's what, pi over 2. And then now this number is my phase shift. Phase shift, and it's a plus, so that would mean left, pi over 4. So that's how that's going to work. And now I'll show you on the picture how you could do that. So I'm going to cheat again, and I've already got cosine drawn, so instead of making this scale a 1, I'm going to cheat and make that a 3 and a -3. That way I've covered my new amplitude. Those are the new highs and lows. My new period's pi over 2. So like I did earlier, I'm going to come back here, and it now stops at pi over 2, which means I need to change all these other values. So what did I do? Well, I was multiplying these by a 4th. So if I multiplied 2 pi by a 4th and it got that, what is 3 pi over 2 times a 4th? Well, that's now an 8. Pi over 4 would go there, and pi over 2 times a 4th, pi over 8. So those are my new values there. And now I'm supposed to pick up this whole graph and shift it left pi over 4. Well, you've really got to pay attention to your scale at this point, because according to my scale, it takes 2 of these dashes, right? 2 marks to go a distance of pi over 4. So I need to take this graph and shift it back to the left by 2 dashes on my scale. So there's 2. So this means this is negative pi over 8, and this is negative pi over 4. I'm just going in the negative direction. And I'm going to do this in a different color. So I'm going to grab this point, kick it back 2 marks. I'm going to grab this point, kick it back 2. This point, kick it back 2, this point, kick it back 2, this point, kick it back 2. Then make sure I play connect the dots with curvy, wavy things. That blue graph is the graph I'm hunting for, and I'm going to erase all the old red here. And if your teacher had said, like, show me a graph from 0 to 2 pi, well, you just better keep making dashes and keep letting this go, like keep, oh, okay, it's doing that. So just kind of keep making it go on out until you get to 2 pi. All right, cool. Hopefully that helped. If not, send me questions or texts or whatever you got, and we'll talk to you later.